Okay, in a real quick video, I want to talk to you about the fundamental theorem of calculus. So it's very important, and it helps you solve something called a definite integral. So before, you saw that you had integrals that looked like the integral of f of x dx. There's nothing here around this integral sign. So there are no numbers or anything there. You just have the integral sign, and that's where you get what we call the indefinite integral. And if you recall, that'll always be equal to the antiderivative plus a constant. So we can have integrals now that have what we call limits. So we can have the integral from a to b of f of x dx. So now this integral has limits. It has a lower limit. This is the lower limit, a, and it has an upper limit, b. And if you heard me read it, you read that the integral from a to b of f of x dx. So the question is, how do you evaluate this? And this is where the fundamental theorem of calculus comes in. So if we let the function f of x be continuous on some closed interval ab, then the definite integral from a to b of f of x dx is equal to the antiderivative at b minus the antiderivative at a. So you notice one thing that's not there when you have definite integrals is that there's no plus c on the right hand side, and that you'll actually get here a real number. So this will be a number. So let's look at an example that we can put this in practice. So what if I wanted to evaluate the integral from 1 to 2 of 2x dx? The first thing I'm going to have to do is I'm going to find the antiderivative, 2x, and that's equal to x squared. We use this vertical line, and that says I'm going to evaluate that between 1 and 2. So I plug in the upper limit into the antiderivative, so that's going to be 2 squared, and I subtract from that what I get when I plug in the lower limit into the antiderivative, which is 1 squared, and that's 4 minus 1, or 3. So the integral from 1 to 2 of 2x dx is equal to 3. Let's try another example. Suppose I had the integral of e to the x dx, and that was between, say, 0 and 1. So the antiderivative of e to the x, of course, is e to the x. I put the vertical line for my limits. So the lower limit is 0, the upper limit is 1. And so this is equal to e to the first power minus e to the 0 power. E to the 0 power is 1. So this is equal to e minus 1. Now there are a couple of very useful properties for definite integrals and all integrals in general. But the integral from a to b of f plus g dx is equal to the integral from a to b of f dx plus the integral from a to b of g dx. So you can split them up. Similarly, the integral of a constant times f of x dx is equal to the constant, I'll put some limits there, a to b, is equal to the constant times the integral of f of x dx, and of course that's also from a to b. And a very useful property is minus the integral from a to b of f of x dx is equal to the integral from b to a of f of x dx. So in this property, notice that the limits here and here change due to this minus sign.